Hello, class. Today we're going to go ahead and go over section 8.4, multiplying and dividing rational expressions. So to begin, let's go over some vocabulary. When they say simplified form, that means the numerator and denominator have no common factors, and that's other than plus or minus 1. So they have nothing in common on top and bottom besides plus or minus 1. To simplify rational expressions, you divide out common factors. So as an example, if you have AC divided by BC, those C's would cancel out and you would have A over B as your simplified form. Let's go ahead and look at example 1. For example 1, we're simplifying x squared minus 8x plus 16 divided by x squared plus 2x minus 24. To simplify this, you first want to factor the top and the bottom of your expression. So for the top, you would have x and x in the first spot of each set of parentheses. And then you would have -4 and -4. On the bottom, two sets of parentheses. First would be x plus 6 and then x minus 4. Once you factor it, that you look for items you can cancel out. So notice x minus 4 and x minus 4 are both on top and bottom, so you'd cancel those out. One x minus 4 on bottom for one on top. This leaves you with x minus 4 over x plus 6. Now here, top and bottom have x in common, but it's with addition and subtraction in between. You only can cancel out if they're factors, which means that it's multiplication. So this is our finalized simplified form. Okay, now let's take a look at multiplying rational expressions. For example 2, it says, what is the simplified form of 5x squared y cubed divided by 3xy to the 4th times 27x to the 5th over 15x to the 4th y? Now, there are a couple ways you can go about simplifying this. You can either multiply the expressions together first, or you can simplify them first and then combine them. So as an example, I notice that on this first expression, you have an x on the bottom and two x's on top, so I can cancel out one set. For the y cubed, I can cancel out 3 on bottom and 3 on top. So this leaves me with 5x on top and 3y on bottom. For the next one, I know 27 and 15 are both divisible by 3. This leaves me with 9 over 5. For the x's, I can cancel out 4 of them, so you only have 1 left on the top, and you have a y left on the bottom. Now, I'm going to go ahead and multiply them together. 5x times 9x is 45x squared. 3y times 5y is 15y squared. And now looking at the entire expression together, I know that top and bottom are both divisible by 15, which leaves me with 3x squared over y squared as my final answer. In example 3, we're going to multiply 20x minus 5x squared over x squared minus x times x squared plus 3x minus 4 over x squared minus 16. So what I'm actually going to do first here is I'm going to factor all of the numerators and denominators. So on the top of the first fraction, 20x minus 5x squared, they're both divisible by 5x. So when I factor out a 5x, I get 4 minus x. On the bottom, I can take out an x to get x minus 1. For the next fraction, on top, I can use two sets of parentheses. It would be x plus 4 times x minus 1. And on the bottom, I get x plus 4 times x minus 4. Okay, so now I can go ahead and multiply all these together if I want. 5x times 4 minus x times x plus 4 times x minus 1 all over x times x minus 1 times x plus 4 times x minus 4. Now I can go ahead and cancel out what the top and bottom have in common. So I can cancel out x minus 1s. I can cancel out the x's. I can cancel out x plus 4s. So what this leaves me with is 5 times 4 minus x over x minus 4. Now 4 minus x and x minus 4 are very close to being the same thing. We can actually fix them so they are. I can factor out on the top a negative 1 from 4 minus x. So if you take a negative 1 out, well, if you factor a negative 1 out of 4, it becomes a negative 4. And if you factor it out of a negative x, it becomes positive x. So notice how you could rewrite that as x minus 4. Okay, so I'm going to take out the negative 1, which means it becomes a negative 5 times x minus 4 over x minus 4, which means I can now cancel out those binomials, and my final answer is negative 5. All right, in example 4, we have x minus 4 over x cubed plus 8 times x squared minus 2x plus 4. Now, that second expression is over 1 when we multiply these together. I do want to factor everything first. So on top of that first expression, x minus 4 cannot be factored. But on the bottom, it's a cube. We can factor this. We'll have a binomial and a trinomial. It'll be x and 2. Then we have x squared and 4. That middle term is a 2x. And then we use SOAP for the sign, so it'd be same. Opposite, always positive. Now I show times x squared minus 2x plus 4. And that is, of course, over 1. So notice if I multiply these two together, we end up having an x squared minus 2x plus 4 on top and on bottom. So that leaves us with just x minus 4 on top, and on the bottom we have x plus 2. That would be the final answer. Next, we're going to go ahead and look at dividing rational expressions. So for this first one, x squared minus 4x minus 21 over 5x plus 15 divided by x squared plus 3x minus 70 over x squared minus 100. So the first thing I'm going to do is to divide fractions. You multiply by the reciprocal of the second fraction. So instead, I'm going to write it as x squared minus 4x minus 21 over 5x plus 15 times x squared minus 100 over x squared plus 3x minus 70. Now I'm going to go ahead and factor everything. So on the top of the first fraction, we get x minus 7 times x plus 3. On the bottom, it's 5 times x plus 3. For the second one, it'd be x plus 10 times x minus 10 on top. And on the bottom is x plus 10 times x minus 7. Now, if you're having trouble factoring quickly, then I suggest asking your teacher for more practice or assistance in that, as you're going to be doing a lot of factoring in this chapter. Now, the next thing we want to do is we actually want to multiply these two fractions together. We want to combine them. So they all become one fraction. Because then you can cancel things out. X plus 3's cancel out, x minus 7's cancel out, and x plus 10's cancel out. This leaves me with x minus 10 on top and 5 on bottom. Since there's no more multiplication on top and bottom, there's nothing else you can cancel out. So this would be our final answer. All right, for example 6, we're dividing 3x squared plus 13x minus 10 over 6x squared. We're dividing that by 3x squared minus 2x. Remember, 3x squared over 2x is like it's over 1. So I'm going to go ahead and flip it and make it multiplication like in the exact last example. So it'd be 3x squared plus 13x minus 10 over 6x squared times 1 over 3x squared minus 2x. Now I'm going to factor. For 3x squared plus 13x minus 10, I get 3x minus 2 times x minus 5 over 6x squared. For this next fraction, I get 1 over. I can factor out an x to get 3x minus 2. Remember, we want to combine these together and then cancel out what's the same on top and bottom. So the 3x minus 2's can cancel out. This leaves me with x minus 5 on top. On the bottom, we have the 6x squared times x. So your final answer would be x minus 5 over 6x cubed. Now that's it for notes today. If you have any questions, be sure to contact your teacher.